Today, 8 billion humans dominate the Earth, from sprawling cities to the most remote corners of the globe. But this was never guaranteed. Imagine a time when our entire ancestral population was smaller than a typical high school, with only 1,280 individuals left alive. For over 100,000 years, humanity's future hung by a thread, a near-extinction event hidden in our DNA until it was finally discovered in 2023. This is the story of how we almost vanished, and how a handful of survivors changed our species forever. Before we begin, let me know in the comments where you're watching from and what time it is. Now get comfortable, snuggle up in your blanket, and let's journey back in time. Imagine opening your eyes, not to the familiar blue sky of your time, but to a world bathed in a softer, more ancient light. It is 900,000 years ago. The air you breathe is clean, carrying the scents of damp earth, wild grasses, and the distant musk of animals you have never seen. There are no cities, no roads, no permanent structures of any kind. There is only the vast, untamed wilderness of a planet in its prime. This is the world before the Great Collapse, a world of a warm and relatively stable climate. For tens of thousands of years, the planet's heartbeat has been a steady and predictable rhythm. Ice ages came and went in relatively manageable 41,000-year cycles. The great ice sheets of the north would advance, and then they would retreat, a slow and patient breath that shaped the continents. Life adapted to this rhythm. Here, in the heart of Africa, the landscape is a sprawling mosaic of lush woodlands and vast open savannas teeming with life. Herds of giant, straight-tusked elephants move through the trees, their immense forms like walking hills. Saber-toothed cats, powerful and patient, watch from the shadows. Countless species of antelope and deer graze on plains that stretch to a horizon, unbroken by anything but the silhouette of a distant volcano. The rivers are clear and full, the forests are deep and ancient, and the world feels eternal. But you are not alone in this world. In this ancient Eden, a new kind of creature is making its way. They are our ancestors, our distant kin. They are species like Homo erectus and Homo heidelbergensis. To our eyes, they would look both familiar and strange. Taller and more robust than us, with powerful builds and faces that feature a heavy brow ridge, they walk fully upright, their eyes constantly scanning their surroundings with a sharp and profound intelligence. They are not masters of this world, they are a part of it, one thread in the impossibly complex tapestry of life. Their populations are small but stable, scattered across the continents in small nomadic family groups. A band might consist of only 20 to 30 individuals, a tight-knit community of parents, children, aunts, uncles and cousins who rely on each other for everything. They are hunter-gatherers, their lives dictated by the movement of the seasons and the migration of the herds. Their technology is simple, yet revolutionary. In their hands they carry tools crafted from stone. An Acheulean hand axe, chipped carefully from a piece of flint or obsidian, is a masterpiece of prehistoric engineering. It is a multi-tool, a knife for butchering a kill, an axe for chopping wood, and a scraper for cleaning hides. It represents a cognitive leap, the ability to see a tool within a raw stone and have the skill to bring it forth. With these simple tools, they can achieve the impossible. They can hunt animals many times their size, process their meat and skins, and defend themselves from the many predators that share their world. A day in, their life is a study in quiet, focused awareness. The men might rise with the dawn, their hand axes ready, to track a herd of gazelle across the savannah. They are masters of endurance, capable of running their prey to exhaustion under the hot African sun. They read the land like a book, understanding the meaning of broken branch, a faint track in the dust, or the distant call of a bird. Meanwhile, the women and children forage closer to their temporary camp. They have an encyclopedic knowledge of the plant world, knowing which roots are edible, which berries are sweet, which leaves can soothe a wound, and which are deadly poison. They dig for tubers with sharpened sticks and gather eggs, insects, and anything else the rich environment provides. In the evening, the band comes together around the glow of a controlled fire. Fire is their greatest ally. It keeps the chilling cold of the night at bay and wards off the great predators that hunt in the darkness. It cooks their food, unlocking precious nutrients and killing dangerous parasites. But more than that, the fire is the heart of their society. Around the flickering flames, they share food, mend tools, and communicate. They strengthen the social bonds that are their ultimate key to survival. The elders pass down their knowledge to the young, the art of tool-making, the secrets of the hunt, the stories of their people. This is a successful way of life. For hundreds of thousands of years, these early humans have not just survived, they have thrived. They have spread from Africa into Asia and Europe, adapting to new climates and new challenges. They're a species at a turning point, constantly learning, constantly innovating, and proving their ability to adapt to changing environments. They are intelligent, resilient, and cooperative. They seem poised for greatness. But they are living on borrowed time. Unseen and unfelt by these small bands of hunter-gatherers, the world is beginning to change in ways they cannot comprehend. The planet's slow, rhythmic breath is becoming erratic. The great engine of the global climate is preparing for a shift, a violent lurch into a new and terrifying state. The world that has nurtured them for 1,000,000 years is about to turn on them with a fury that will bring their entire species and the human story itself to the very brink of a final and absolute extinction. The age of stability is ending. The great cooling is about to begin. For a time that feels like forever, the world has been kind. But the planet is a restless and complex machine, its gears turning in cycles that span millennia, driven by the slow, gravitational waltz it dances with the sun and other planets. Deep within these celestial mechanics, a subtle shift is occurring. A change in the Earth's orbit and tilt, so infinitesimal that no living creature could possibly notice, begins to alter the amount of sunlight reaching the poles. The planet's steady, 41,000-year heartbeat begins to falter. The age of predictability is over. Around 930,000 years ago, the first signs of this new, terrifying reality begin to manifest. It does not happen all at once. It is a slow, creeping cold that seeps into the world over generations. The winters grow a little longer, the summers a little cooler. The great ice sheets in the north, which used to retreat reliably, now begin to hold their ground, and then they begin to grow. This is the beginning of a new climate regime, a shift into brutal 100,000-year ice age cycles. The planet is entering a deep freeze unlike anything our ancestors have ever known. In the north, the glaciers become monsters, mountains of blue-white ice miles high that grind slowly across the continents. They're so immense, their weight so great, that the very bedrock of the earth sinks beneath them. As these glaciers grow, they lock up colossal amounts of the world's fresh water, and the oceans themselves begin to shrink. Sea levels plummet by hundreds of feet, exposing vast new coastlines and creating land bridges between continents that were once separated by the sea. But it is not the ice that is killing your people. It's what the ice does to the rest of the world, especially to Africa. Imagine the great northern glaciers as a kind of atmospheric dam. Their sheer size and the cold air they generate disrupt the weather patterns that have governed the planet for eons. The monsoons, the life-giving rains that have fed Africa's rivers and nourished its savannas for millions of years, become weak and erratic. The rains that once came like clockwork now fail to arrive. At first, it feels like a drought, a bad season. The elders of your band tell stories of similar times, assuring the young that the rains will return. But they don't. Not really. The next season is just as dry, and the one after that is even worse. This isn't a drought. This is the new normal. Scientists today have a name for what happened to the continent: aridification. It didn't just get drier, it got catastrophically drier. You're watching your world die. The lush, green savanna that your parents hunted on is turning a sickly brown. The tall grasses replaced by thorny scrubland. The scrubland in turn is surrendering to sand and dust, turning into a barren desert. The great rivers that ran year-round, that provided you with water and attracted game, are now seasonal streams. Soon they are nothing but dry, cracked beds of mud that snake through a desolate landscape. The waterholes where you and your family drank alongside elephants and antelope are disappearing, one by one. The world is transforming into an arid wasteland, and it is happening faster than your people can adapt. This environmental collapse triggers a catastrophic breakdown of the food chain. The plants are the first to go, withering under a sun that now seems hostile. Without the plants, the great herbivores begin to starve. The animal populations that once seemed endless begin a steep decline. The fossil evidence is stark. Most of the large mammals in Africa went extinct during this period. Antelope species that had thrived for millions of years simply vanished from the earth. Elephant and rhino populations crashed. The world grows quiet. The thunder of migrating herds fades into a memory. For our ancestors, this is a disaster of unimaginable proportions. Their entire existence is built around the abundance of these animals. They are the source of food, of hides for warmth, of bone for tools. As the animals disappear, a desperate and gnawing hunger sets in. Food becomes scarce. The hunts that were once successful now end in failure more often than not. The familiar territories that have sustained your band for generations become barren and hostile. Every day becomes a desperate struggle for survival. The focus of life narrows to 3 simple, brutal imperatives: find water, find food, and do not die. The world that was once a Garden of Eden, a place of immense abundance, has become a harsh and unforgiving enemy. The sun beats down from a cloudless sky, baking the cracked earth. The wind is a hot, dry breath that carries only dust. Hope becomes as scarce as water. Your people are faced with a terrible choice. You can stay in the lands of your ancestors, the places where your grandparents were born and died, and watch as your world turns to dust around you. Or you can leave, abandoning the only home you have ever known to venture into the unknown, hoping to find some last refuge, some pocket of the world that the great drying has not yet touched. It is a choice between a slow, certain death and a dangerous, uncertain future. Most would choose poorly. Most would perish. But this is not just a story of death. It is a story of survival. For a tiny few, this planetary crisis would become an evolutionary crucible, a fiery test that would forge a new kind of human, one capable of enduring the impossible. But first, they would have to witness the near-total collapse of their species. They would have to live through the great dying. The world you once knew is gone. The great drying, the slow and merciless advance of the arid deserts was not a temporary hardship. It was a verdict. And now the sentence is being carried out across the entire continent. The intricate web of life, woven together over millions of years, is unravelling with breathtaking speed. The food chains are collapsing in a cascade of extinction. The plants, starved of water, withered and died first. Then, the great herbivores that depended on them began to vanish. Their massive bones now litter the dusty plains, monuments to a world of plenty that no longer exists. And now, the predators and scavengers who fed upon the herbivores are following them into oblivion. The saber-toothed cats, the giant hyenas, and our own ancestors are all caught in the same, inescapable trap of starvation. Your small band of humans is now a fragile island in a sea of emptiness. The world has grown quiet and vast. The neighbouring groups you once traded with, shared stories with, and found partners among are gone. You don't know if they moved on or if they starved. You only know that you are alone. Human groups have become completely isolated and fragmented, scattered across a hostile landscape like the last remaining embers of a once great fire. Your life is now defined by a single, desperate imperative: movement. You're constantly migrating in a frantic search for food and water. You walk from sunrise to sunset, your eyes scanning the barren horizon for any sign of life, for the glint of a distant waterhole, for a lone, starving animal that might provide one more meal. Your ancestral lands, once a reliable provider, have become a series of deadly traps. Hope is a resource more scarce than water. This is the reality on the ground. But the true, horrifying scale of this catastrophe would remain a secret for nearly 1 million years, a ghost story hidden deep within our own DNA. It would take the development of advanced 21st century science to read this story, to finally understand what happened to our ancestors during this terrible time, and what the science tells us is almost impossible to believe. The genetic evidence, pulled from the genomes of thousands of modern humans, is stark and unambiguous. This was not just a difficult period, it was a near-extinction event. Nearly 99% of the entire ancestral human population was wiped out. The mathematical models scream that something catastrophic happened. They show that the number of breeding individuals in our direct lineage crashed from a population of perhaps 100,000 to a tiny, almost statistically insignificant number. Only around 1,280 individuals survived. Let that number sink in. Not 1.28 million. Not 128,000. Just 1,280 breeding individuals left on the entire planet. That is smaller than the student body of a typical high school today. The entire future of humanity, the future that would lead to art, to agriculture, to cities, to spaceships, to us, was resting on the shoulders of a group so small they could have all been wiped out by a single flood or a localized disease. And this was not a brief, sharp crisis. The human population did not crash and then immediately recover. It crashed, and it stayed crashed. For nearly 100,000 years, or to be more precise, for 117,000 years, our ancestral population remained at these critically low, almost unsustainable numbers. This is a span of time that is difficult for our modern minds to comprehend. It is longer than our own species, Homo sapiens, has existed on this planet. For 4,000 generations, our ancestors lived on the absolute razor's edge of extinction. When a species population gets this small, it usually doesn't bounce back. It enters what biologists call the extinction vortex. The gene pool becomes dangerously shallow. Inbreeding becomes inevitable, leading to a rise in genetic disorders and reduced fertility. The population becomes incredibly vulnerable. Random disasters can easily wipe out the entire group. Most species that hit numbers this low simply vanish forever. And by all rights, we should have vanished too. But we didn't. Somehow, against all odds, that tiny flame of humanity was not extinguished. So where did these 1,280 souls survive? The genetic and archaeological evidence points to a few likely survival regions, pockets of stability in a world of chaos. Somewhere in East Africa, perhaps in the highlands of modern-day Ethiopia, or nestled within the Great Rift Valley, there must have been a refuge. Imagine a place that the Great Drying never fully conquered. A mountain range that still caught enough rainfall to support a small, isolated forest. Or a deep valley fed by an underground aquifer that kept springs flowing when everything else had turned to dust. These refuges would have been like lifeboats in a planetary shipwreck. They would have required a stable environment with just enough resources and few stresses to allow this tiny group to survive for over 100,000 years. In these isolated sanctuaries, while the rest of the human world was dying out, a tiny population held on, keeping the story of humanity alive when it should have been snuffed out forever. Their long, desperate watch was just beginning. Welcome to the long winter of humanity. You're one of the survivors, one of the 280. The world is a vast, empty canvas, and your existence is a tiny, flickering flame in a profound and overwhelming darkness. The crisis that wiped out 99% of your people was not a swift, cleansing fire. It was a slow, grinding siege that has now lasted for thousands of years. This is the new reality. There is no memory of a better time. The stories of the old world of endless herds and reliable rains are now just myths, whispered around a meagre fire to children who have never known anything but this harsh, broken landscape. Forget everything you think you know about progress. During the bottleneck, there was no progress. There was only survival. Your daily life has been stripped down to a brutal minimalist routine. Wake up, find water, find food, and do not get killed. Repeat for your entire life, and for the lives of your children's children's children for the next 100,000 years. Water comes first, always. In this desiccated world, water is life, and the knowledge of it is the most sacred text your people possess. You have developed an almost supernatural ability to read the land, to spot the subtle signs of underground moisture, to predict which dried-up riverbeds might still hold a hidden pool of stagnant water. Your band may have even learned to dig crude wells, scraping away at the hard earth with sticks and stones for days, hoping to reach the damp soil that promises a few more precious mouthfuls of life-sustaining liquid. Food is a constant gnawing obsession. The great game is gone. The massive, lumbering beasts your ancestors hunted are now just sun-bleached bones half buried in the dust. You cannot afford to be a specialist. You have become what anthropologists call a dietary generalist. You eat everything. Absolutely everything. Insects are a staple. Termites, crickets, beetle larvae, pound for pound. They are some of the most nutritious foods on the planet, rich in protein and fat. You eat roots and tubers, the tough, starchy energy stores of plants that grow underground, protected from the relentless sun and drought. Your mind is a catalogue of the plant kingdom, a library of knowledge passed down through generations. Which plants are safe to eat, which are toxic unless prepared in a specific way, and which can be stored for the lean times that are now the only times you know. You are an expert at finding eggs, raiding the nests of birds and reptiles, careful to leave just enough so the creatures might return to lay more. Meat, when you can get it, is a rare and precious luxury. It comes from small animals, an injured gazelle, an old warthog dying of thirst, or the carcass of something larger that you might be lucky enough to scavenge. And this is where fire becomes the absolute centre of your universe. Your ancestors used fire, but for you, it is the very difference between life and death. Cooking the meat kills the parasites and bacteria that could sicken and kill your entire family. More importantly, the act of cooking breaks down tough proteins and makes nutrients far more available, allowing you to wring more calories from the same small piece of food. This technology is even more revolutionary for plants. Many of the roots and tubers you rely on are indigestible or even poisonous when raw, but when cooked, they are transformed into life-giving carbohydrates, opening up a whole new menu of survival. But fire does more than just feed you, it extends your day. After the sun sets, the darkness belongs to the great predators, but your campfire creates a circle of light and safety. It allows you to work on tools, to share information, to plan for the next day's desperate search for food. Most importantly, it allows you to strengthen the social bonds that are now your single greatest weapon. In a world where only 1,280 breeding individuals of your kind exist, cooperation is not a philosophy. It is a biological imperative. Your band is likely a small group of 20 to 30 people, and they are all your family. You have to be. With a gene pool this small, you cannot afford to be picky about partners. Inevitably, inbreeding is common, and with it, a higher rate of genetic disorders, birth defects, and reduced fertility. Every single birth is a miracle, and every individual is precious beyond measure. You cannot afford conflict. A single adult lost to a fight is a devastating blow to the entire group's chances of survival. So you learn to cooperate with a skill that modern diplomats would envy. You learn to share resources, even when they are painfully scarce. You learn to care for the sick and the injured instead of abandoning them, because you understand that their survival is your survival. And most crucially of all, you learn to share knowledge. When one person finds a new, reliable water source, that information is shared with the group instantly. When someone discovers a new way to process a toxic plant to make it edible, that knowledge becomes a part of the band's collective wisdom. This is not just being nice, it is a critical survival strategy. Losing the accumulated knowledge of an elder when they die could be a catastrophe, a death sentence for the whole group. So you become obsessive about teaching your children. You pass down everything: how to read the tracks of an animal, how to predict the weather from the clouds, how to make and maintain your tools, how to find your way back home. This is natural selection at its purest and most brutal. For 117,000 years, your world is an evolutionary pressure cooker. Generation after generation, the environment is relentlessly selecting for specific traits. Not strength, not aggression, but intelligence, problem-solving skills, social cooperation, and the capacity to learn and transmit complex information. Individuals who can't get along, who can't learn, who can't contribute, they die, and their genes die with them. Individuals who are smart, adaptable, and willing to work together live long enough to have children and pass on those very traits. You are living through an extended near-death experience for your entire species. It is a brutal, terrifying, and merciless existence. But as you huddle with your family around the flickering light of the fire, sharing the meagre scraps of the day, you do not know that your struggle is doing more than just keeping you alive. It is forging you and all of humanity into something entirely new. Life inside the bottleneck was a relentless, day-to-day struggle for existence. But beneath the surface of this desperate fight for survival, a profound transformation was taking place. Invisible to the individuals living through it, this 117,000-year crisis was fundamentally rewriting what it meant to be human, both in our culture and in our very genes. The most dramatic change happened at the molecular level, an event so rare and so significant that it has been called the most important crime scene in human history. Within the tiny, isolated population of survivors, an unprecedented genetic accident occurred. 2 of our ancestral chromosomes fused together, merging into one. This is not a subtle mutation, it's a massive reorganization of our genetic blueprint. It is the reason why modern humans have 23 pairs of chromosomes, while our closest living relatives, chimpanzees and gorillas, have 24. Such a massive fusion is incredibly rare and usually detrimental, but in a population so small, genetic quirks that would normally disappear can spread and become universal with astonishing speed. If one of the 1,280 survivors had this fusion and managed to reproduce, their children would carry it. Within a few generations, this unique genetic marker could have spread through the entire human population. Today, every single human on Earth carries this fused chromosome. It's known as chromosome 2, and it is a permanent, indelible scar from our near extinction. We are all, quite literally, marked as the descendants of those few survivors. But this fusion may have done more than just change our chromosome count. Some scientists believe the event was a trigger for critical changes in our evolution. The genes located near the fusion site are known to affect neural function and brain development. It is entirely possible that this genetic shake-up, this biological consequence of our near-death experience, contributed to the evolution of the larger, more complex human brains that would define our future. Our very intelligence might be an accidental byproduct of our brush with extinction. This internal genetic evolution was matched by an external cultural one. The archaeological record from this period is frustratingly sparse, what anthropologists long called the fossil gap. Now we know why. With so few humans on the planet, the chances of any of them leaving behind fossils were incredibly small. But the few artifacts we do have tell a fascinating story. The stone tools become more sophisticated. The simple choppers of the past give way to the more advanced Acheulean hand axe, a versatile and standardized tool that required more planning and skill to create. The tools from this period also show what archaeologists call cultural convergence. Similar tool designs begin to appear in different regions at roughly the same time. This suggests that the surviving human groups were not completely isolated. They were part of a larger network. The 1,080 survivors were not all huddled together in a single valley. That would have been a recipe for disaster, as a single flood or disease outbreak could have wiped them all out. Instead, they likely formed what biologists call a metapopulation, a network of smaller, scattered groups, perhaps 20 or 30 people each, connected by kinship and trade, but living independently enough that no single catastrophe could destroy them all. These scattered groups would have met periodically, exchanging not just goods, but knowledge and, crucially, genes. This network structure provided the resilience that allowed humanity to weather the 117,000-year storm, and perhaps the most important innovation of all was the mastery of fire. While early humans had used fire opportunistically, it is around the end of the bottleneck, about 800,000 years ago, that we see the first clear archaeological evidence for its systematic and controlled use. This timing is almost certainly not a coincidence. The mastery of fire was a game changer, a technology that provided warmth, protection, and a way to unlock far more nutrition from their food. It was likely the key technology that finally allowed human populations to break out of the bottleneck and begin to grow again. Innovation, born from desperation, became the ultimate key to survival. The survivors who emerged from the bottleneck were not the same people who had entered it. They had been transformed by 4,000 generations of intense natural selection. They were genetically distinct, marked by a unique chromosome. They were technologically more advanced, with better tools and the power of fire at their command. And they were socially more complex, bound together in resilient networks capable of sharing knowledge across vast distances. The foundations for future human evolution, for everything that was to come, had been laid not in a time of plenty, but in the deepest crucible of our species' suffering. The harshest trial was ending, and humanity was finally ready for its long recovery. The Earth breathes again. After 117,000 years of a desperate, suffocating winter, a change finally comes. Around 813,000 years ago, the great and terrible rhythm of the climate begins to shift once more. The celestial mechanics that plunged the world into a deep freeze realign, and a slow, life-giving warmth begins to seep back into the planet. The first signs are subtle: a rainy season that is slightly more reliable, a spring that arrives a little earlier, but over the course of centuries the change is undeniable. The great ice sheets in the north begin their long retreat. The immense atmospheric dam that choked the life from Africa dissolves, and the monsoons return. The rains, when they come, are no longer a brief, mocking sprinkle, but a deep, nourishing deluge that soaks into the cracked and thirsty earth. The world is reborn in a great explosion of green. The grasslands, which had retreated into tiny, isolated pockets, now begin to expand again, rolling across the barren plains. Rivers that had been dry for millennia begin to flow, carving new paths through the ancient landscape. The ecosystems, shattered and broken for so long, begin the slow and patient work of healing themselves, and with the return of the plants, the animals return. Small herds of antelope, then larger herds of zebra and wildebeest, reappear on the plains. The silence of the world is broken by the sounds of life. And what of your people, the descendants of the 1,280 survivors? They are no longer the same species that entered the bottleneck. They have been tested by 117,000 years of the most intense natural selection imaginable. They have been forged into something new, something stronger, something more adaptable. They are armed with better tools, with the mastery of fire, and with complex social systems built on a foundation of absolute cooperation. When the climate began to improve, they were ready. They were spring-loaded for success. the human population doesn't just recover, it explodes across the landscape. The growth is not slow or gradual, it is rapid, almost explosive. Within just a few thousand years, a mere blink of an eye in evolutionary terms, the descendants of the bottleneck survivors multiply from just over 1,000 to hundreds of thousands, and perhaps even millions. They spread out from the secret refuges that had sheltered them during the crisis, and begin to colonize territories that have been empty of humans for ages. They carry with them all the survival skills learned during the long winter, the genetic and cultural adaptations that allowed them to survive when death seemed certain. But here, the story takes its most fascinating turn. They do not expand as one single unified family. The bottleneck, which had brought humanity to the brink of a singular end, now becomes the catalyst for its greatest diversification. The intense pressure and subsequent release had set the stage for the most important speciation event in our lineage. Around 800,000 years ago, that single population of survivors began splitting into three distinct groups, three separate evolutionary paths that would eventually become the three most successful human species in history. Think of it like a river that has been forced through the narrowest possible channel for 100,000 years. When the constraint is finally removed, the water doesn't just flow. It erupts in every direction, carving new channels, creating new pathways. That is what happened to human evolution after the bottleneck. The first group stayed in Africa. They would remain in the mother continent, continuing to adapt to its fluctuating and challenging environments. The ongoing pressure of a variable climate would continue to select for intelligence, adaptability, and problem-solving skills. Over the next several 100,000 years, this population would develop the key features of modern humans: larger brains, a more slender bone structure, and the capacity for symbolic thought. They were our direct ancestors, the lineage of Homo sapiens. A second group moved north and west, eventually pushing into Europe and Western Asia. Here they found a very different world, a land that was colder, more seasonal, and dominated by the lingering effects of the ice ages. They adapted quickly, evolving robust, powerful bodies designed to conserve heat and withstand the brutal cold. Their nasal passages grew larger to warm the frigid air, and their entire culture became centered around the systematic strategic hunting of massive Ice Age mammals like the woolly mammoth and the woolly rhino. They became the Neanderthals, the masters of Ice Age Europe. A third group went east. They spread across the vast continent of Asia, a journey that is still shrouded in mystery. We know less about them because their fossils are incredibly rare, but we know they were incredibly successful because they left their genetic signature in the DNA of modern human populations across Asia and Oceania. They were the Denisovans. They were masters of adaptation, with some groups developing unique genetic traits that allowed them to live in the thin air of the high Himalayan plateau, while other groups may have become skilled seafarers, reaching remote islands in Southeast Asia thousands of years before any other human species. 3 continents, 3 distinct evolutionary paths, all born from a single, tiny group of survivors. For the next several 100,000 years, these 3 human species would evolve in relative isolation, each becoming a master of its own domain. But they all carried the indelible mark of their shared origin. They all carried the fused chromosome 2, the molecular scar of the bottleneck. And they all shared the low genetic diversity that was the lasting legacy of the time their world almost ended. The long recovery was complete. The age of competition was about to begin. For nearly 1 million years, the story of the great collapse and the long recovery remained untold, a secret locked away in the deepest recesses of our biology. The individuals who lived through it left no written records, no monuments to their struggle. The only evidence was circumstantial, a series of tantalizing and deeply puzzling clues that haunted the scientists of the 20th and early 21st centuries. The first clue was the strange and undeniable fact of our own genetic uniformity. For decades, as geneticists began to map the DNA of life on Earth, they noticed that humanity is weirdly, almost unnaturally similar. Our genetic diversity is bizarrely low compared to other animals. A small group of chimpanzees living in a single forest in Africa has far more genetic variation than all 8 billion humans on the entire planet combined. This is not normal. It is the classic signature of a population bottleneck, a time when a species was reduced to a very small number of individuals, losing a huge amount of its genetic variation in the process. Scientists knew a bottleneck had happened, probably when our ancestors first migrated out of Africa some 60,000 years ago, but that event couldn't explain the sheer scale of the missing diversity. The second clue came from the Earth itself. Anthropologists had long been troubled by the fossil gap, a mysterious period in the human story between roughly 950,000 and 650,000 years ago, from which there are almost no human fossils to be found anywhere in Africa or Europe. For a species that had been successfully expanding, it was as if our ancestors had simply vanished from the world for 200,000 years. These were the clues to a prehistoric cold case of epic proportions. Scientists knew a crime had been committed, but they had no body and no murder weapon. The older methods of genetic analysis were like trying to read a book through a keyhole. They could see that something had happened in our past, but they couldn't see the full picture. The truth remained just out of reach, hidden in the statistical noise of our DNA. The breakthrough came from an international team of geneticists and computational biologists, led by researchers like Wangju Hu at the Chinese Academy of Sciences. Their investigation didn't happen in a dusty trench under the hot sun. It happened inside the silent, humming circuits of some of the world's most powerful supercomputers. They had developed a revolutionary new set of computational tools, a method called FitCoal, that could do what was previously impossible. Instead of peeking through the keyhole, this new technique could kick the door wide open. It allowed them to analyze thousands of genomes simultaneously, tracing the intricate patterns of genetic lineages back in time for nearly 1 million years with stunning precision. They fed the DNA of over 3,000 modern people from populations all around the world into their models and set them running, asking the machine to reconstruct the story of our ancient population size. And then they saw it. As the model tracked our lineage backwards through time, everything looked normal. And then, around 930,000 years ago, the genetic signatures simply collapsed. It was like watching a movie where suddenly 99% of the actors disappear from the screen. The mathematical models were screaming that something catastrophic had happened, but the numbers were so extreme, the scientists themselves didn't believe them at first. A population crash of 98.7%. A surviving population of just 1,280 breeding individuals. It had to be an error, a glitch in the analysis. Because if the numbers were right, it meant our ancestors had been reduced to a population smaller than a village, clinging to existence for over 100,000 years. The lead scientists spent years trying to prove themselves wrong. They double-checked, triple-checked, and reran the analysis again and again with different methods, with different datasets, desperately looking for the mistake. But every single time, the result was the same. The ghost in our genes was real. In 2023, they published their findings in the prestigious journal Science, and the scientific community was stunned. It was a discovery that sent shockwaves through the fields of anthropology and genetics. It wasn't just the sheer severity of the bottleneck that was so shocking, but its unbelievable duration. Most population bottlenecks are like a flash flood, a sudden, sharp disaster, followed by a relatively quick recovery. But this wasn't a flash flood. This was a 100,000-year ice age for our entire species. The discovery instantly solved the two great mysteries. The fossil gap wasn't a gap in the record. It was a reflection of reality. There were no fossils because there were barely any humans left alive to leave them. And our strangely low genetic diversity was the permanent echoing wound from the moment we were almost erased from the Earth. The discovery of the bottleneck had permanently reshaped our understanding of human evolution. It proved that our story was not a steady, triumphant march of progress. It was the story of an apocalypse, a near-total extinction, and the improbable survival of a tiny forgotten band of ancestors who, against all odds, refused to let the human story end. The story of the bottleneck is not just an ancient history of hardship and recovery, it is our story. The 117,000-year trial by fire did more than just leave a scar on our genome. It fundamentally reshaped what it means to be human. The consequences of that near-extinction event are our paradoxical inheritance, a legacy of both profound weakness and unparalleled strength that defines our species to this day. To understand ourselves, we must first understand how that catastrophe was both an end and a new beginning. It was the event that nearly erased us from existence, and yet, without it, Homo sapiens might never have existed at all. Let us first examine the scars. The deepest wound inflicted by the bottleneck was the catastrophic loss of our genetic diversity. As our ancestors dwindled to just 1,280 breeding individuals, a vast library of genetic information was lost forever. Scientists estimate that we lost about 65% of our total genetic diversity during this period. To put that in perspective, the famous out-of-Africa migration around 60,000 years ago, long considered a major bottleneck, reduced genetic diversity by only about 15%. The ancient crisis was an order of magnitude more severe. This genetic impoverishment has consequences we're still living with today. If you have ever wondered why humans seem so susceptible to infectious diseases compared to other mammals, why a virus can sweep through our global population with such devastating efficiency, the answer lies in the bottleneck. We're all much more genetically similar than a species with a population of 8 billion should be. This lack of variation means that we have fewer immune system defences in our collective toolkit. A pathogen that finds a way to exploit one person's genetic weakness has a much higher chance of being able to exploit everyone's. Furthermore, the bottleneck acted like a genetic sieve that sometimes caught and locked in harmful traits. In a large, healthy population, rare and detrimental genetic mutations are often weeded out by natural selection. But when you're down to just over 1,000 individuals, strange things can happen. Genetic quirks that would normally disappear can, by sheer chance, get locked into the entire gene pool of the species. Many genetic disorders that persist in human populations today may be echoes of that ancient crisis. In a twisted way, every genetic vulnerability we carry is a testament to the fact that our ancestors were tough enough to survive when survival itself seemed impossible. Our weakness is the proof of our greatest triumph, but if the bottleneck left us with scars, it also bestowed upon us a set of extraordinary gifts. The same evolutionary pressure cooker that crippled our genetic diversity also forged the very traits that make us unique. It selected for a suite of cognitive and social abilities that allowed us to not just recover, but to eventually dominate the entire planet. Consider our capacity for cooperation. Have you ever wondered why humans can work together in groups of thousands or even millions, building cities, running nations, creating global networks, while our closest relatives, chimpanzees, max out at maybe 50 individuals before their societies collapse into conflict? The answer was forged in the bottleneck. For 4,000 generations, our ancestors lived in populations so small and under such intense pressure that cooperation wasn't just a good idea. It was the only way anyone survived. Individuals who couldn't get along, who were selfish, who could not share or collaborate, died, and their genes died with them. Those who could build trust, share knowledge, and work together for the common good lived long enough to pass on their genes. Generation after generation, natural selection was relentlessly fine-tuning our capacity for collaboration. We are the descendants of the ultimate team players. Then there is our obsession with teaching and learning. Humans spend an astonishing portion of their lives just showing their children how to do things. This teaching instinct is not a cultural quirk. It is a survival strategy that was hardwired into our brains during the bottleneck. In a world with only a few hundred people in your entire social network, the death of a single elder could mean the loss of a library's worth of crucial information. Losing the knowledge of how to find water in a dry season, or how to process a toxic but life-saving root could doom your entire group. Our ancestors, who were the best at transferring information to the next generation, the most patient teachers and the most eager students, had a massive survival advantage. We didn't just survive the crisis, we became a species addicted to learning and sharing what we learned. This drive to learn is coupled with our unparalleled ability as problem solvers. Our affinity for tools, from the first stone axe to the smartphone, is a direct legacy of the crisis years. When your environment has completely collapsed, when all the old ways of life have failed, the only path forward is innovation. Our ancestors were forced to figure out better ways to get food, make fire and build shelter, or they would die. We evolved into a species that sees the entire world as a set of raw materials for solving problems. This cognitive flexibility, the ability to adapt our strategies and technologies when circumstances change, was perhaps the single most important trait selected for during the long winter. While species like the Neanderthals would later become incredibly good at perfecting a specific set of survival strategies, our lineage was selected for the ability to handle whatever came next. Perhaps the most profound legacy of the bottleneck, however, is what it tells us about ourselves as a single unified species. Right now, in the 21st century, there are still people who believe that the superficial differences between human populations, skin colour, facial features, are meaningful in some deep biological sense. The discovery of the bottleneck obliterates that thinking completely. The genetic evidence is unequivocal. Every single person on Earth today, from the mountains of Tibet to the Amazon rainforest, from the skyscrapers of Tokyo to the plains of the Serengeti, is a descendant of that same tiny group of 180 individuals who survived 900,000 years ago. We have only been separated by migrations for a few tens of thousands of years, a mere blip in evolutionary time. The genetic differences between any two human populations on opposite sides of the planet are smaller than the differences you would find within a single, small population of chimpanzees. There is no them. There is only us. We're all recent cousins, a single family shaped by the same history of survival against impossible odds. The catastrophe was both an end and a new beginning. It was the end of the world of Homo erectus and the other early humans. It was a terrible silent apocalypse that erased countless lineages from existence. But it was also the violent creative spark that gave rise to our own. The bottleneck was the great filter. It selected for the precise combination of traits, intelligence, cooperation, adaptability, and technological ingenuity that would define the three human species that emerged from the recovery. It created the evolutionary crucible from which modern humans, Neanderthals and Denisovans, would be born. Without that immense environmental pressure, without that near-extinction event, the unique evolutionary path that led to us would likely never have happened. We are the children of the survivors, walking proof that sometimes the greatest strength can be forged in the fires of the most profound hardship. So here we are, 8 billion humans living on Earth. Our species has built skyscrapers that pierce the clouds, sent robotic explorers to the surface of Mars, and created a global network of information that connects us all in an instant. The metro area of Tokyo alone holds 14 million people. Lagos, over 15 million. Our cities are so massive they glow like man-made galaxies against the darkness of space. We have dominated this planet like no species ever has before. We are, by any measure, the most successful species in the history of life on Earth, and yet every single one of us, every person in those sprawling cities, every person who has ever created art or music or technology, every child being born right at this moment, owes their existence to a miracle. We are all the descendants of a tiny forgotten band of ancestors who 900,000 years ago numbered only 1,280 breeding individuals. Take a moment to truly absorb that. The entire future of humanity once rested on a population smaller than a village, a group so fragile that their existence was a statistical improbability. For 117,000 years, our lineage balanced on the sharpest edge of extinction. It was a period longer than our own species, Homo sapiens, has even walked the earth. Through countless generations, through ice ages and droughts, through the extinction of nearly every other large mammal on their continent, they held on. Think of the things that could have gone wrong. A single, localized disease could have swept through their small, inbred population and ended our story before it truly began. A single volcanic eruption, a prolonged flood, or one more season where the rains failed to arrive could have been the final, fatal blow. Humanity's existence was not a certainty. It was a fluke, a desperate gamble against impossible odds. This discovery, hidden in our genes until 2023, is more than just a fascinating piece of our ancient past. It is a profound and deeply humbling mirror. It forces us to confront our own fragility. As we stand here today, masters of our world, it is easy to feel invincible, to believe that our technology and intelligence place us above the laws of nature. The bottleneck is a stark and terrifying reminder that this is not true. It is a warning, written in the language of our own DNA, that our success is never guaranteed. Our ancestors faced a global climate crisis, a period of rapid environmental transformation that destabilized their entire world and pushed them to the very brink of annihilation. Today, we find ourselves facing another period of rapid environmental change, a new climate crisis of our own making. The story of the bottleneck whispers a chilling lesson to us across the ages. We are not invulnerable. The planet we live on is a powerful and complex system, and when that system is pushed out of balance, the consequences can be catastrophic, even for the most intelligent and adaptable species. But the legacy of our survival is not just one of fragility, it is also one of hope. It is a testament to our almost unbelievable resilience. The ancestors who made it through those 117,000 years were not just lucky, they were the ultimate survivors. The crisis selected for the very best of what it means to be human. It amplified our intelligence, it supercharged our capacity for innovation, and most importantly, it hardwired our ability to cooperate. The very traits we need to navigate the global challenges we face today, our ability to share knowledge across vast networks, to work together to solve complex problems, to adapt our behavior in the face of new threats, are the same traits that were honed to a razor's edge in that ancient evolutionary crucible. We are the descendants of those who refused to give up. That resilience is not just in our history books, it is in our blood, in our minds, and in our social instincts. The bottleneck is both a warning of what can happen when a world falls apart and a promise that we carry within us the capacity to survive almost anything. We've travelled back 900,000 years to a world that was both a paradise and, soon after, a living hell. We have witnessed the slow, agonising collapse of a stable world, a climate catastrophe that wiped out 99% of our ancestors and left a mere handful of survivors to carry the fate of our entire lineage. We have walked with them through their 117,000-year winter, a period of intense hardship that forged them into something new, something stronger. And we have seen their descendants, the children of the bottleneck, not only recover but explode across the planet, diversifying into the three great human species and eventually giving rise to the world we know today. The final answer to the question, could you have lasted a day, is an absolute and undeniable no. But that is the wrong question. The right question is, how did they last for 117,000 years? They did it by abandoning old ways of thinking, by innovating when their lives depended on it, and by understanding that in the face of an existential threat, the only way to survive was together. The story of the Great Bottleneck is the ultimate story of humanity. It is the story that explains our greatest strengths and our most persistent weaknesses. It is the event that made us the hyper-cooperative, problem-solving, culture-building species that we are. It proves that our entire global civilization of 8 billion people is one single, recent family, all descended from a tiny band of survivors who, through sheer grit and ingenuity, kept hope alive when the world had turned to dust. As you drift off to sleep tonight, remember them. Remember the Vostauchhundredeighty. They are not distant, abstract figures. They are you. Their struggles are etched into your chromosomes, their resilience is in your capacity to learn and to love, and their survival is the reason you are here to dream at all. Their story is over, but ours is still being written. And the greatest lesson they left for us is that even in the darkest of times, when the future seems impossible, a few determined souls can be tough enough, smart enough, and cooperative enough to ensure that the story continues.